All right, so moving into our next unit, so kind of jumps here. Technically, it's module 18. So we're working at triangles still, adding on this idea, and we talked a little bit about this when we did some proofs because it came up, is this idea of corresponding parts of congruent figures are congruent, or when we did this with triangles and the proofs we did, corresponding parts of congruent triangles are congruent. So CP, CTC is what that looked like. All right. And basically what that states is if two figures are congruent, then corresponding sides are congruent and corresponding angles are congruent. Okay, so the parts that match up are congruent. And what congruent means, just a reminder, corresponding sides have the same length, so that's what they mean is congruent, and thus they have the same measure, the numerical value. Therefore, they are equal. Okay, and then the equal deals with actual numeric values. Congruent is just talking about this length that's an unmeasured. This also holds true for angles as well. So big, bold, squared. Sure, let's even highlight it. Pay special attention to the order of the letters in the congruent statement because they will tell you what parts match up. So let's take a look at this first example here. Write congruent statement for all sides and angles, and we're given that triangle ABC is congruent in triangle DEF. Okay, so again, unless the diagram says that they are drawn to scale, you can't trust the diagram, and this is why paying attention to the congruent statement is huge. So then we know that angle A is going to be congruent to angle D because they're in that order. Then angle B is congruent to angle E. Leaving us with angle C is congruent to angle F. And as far as sides, then we look at the two letters together. So we get AB is congruent to DE. And then BC is congruent to EF. And last, then you have CA and FD. CA is congruent to FD. All right. So there's our congruence statements. So let's take a look at, we want to find the length of DE. So then we know that DE from here is congruent to AB, and then we know that AB is 2.6, so then length of DE is 2.6 as well. And then we have angle measure B is what we're looking for, and we know that B is congruent to E, and then we go over here, so E is 65, so then we can state that the measure of angle B is equal to 65 degrees. All right. Then we have a second example here. So I'm going to let you guys work on this one here, and you're actually going to answer some questions in Edpuzzle. All right, and then here are your answers to those as well. All right, and there you go for those answers there. All right, so here's another example. We're told that triangle ABC is congruent to triangle DEF. We want to find the length of AB and find the measure of angle D. So see if you can't figure those out, and again, you'll answer those questions. And there you go with your answers for 3A and B. All right, little reflection for you. Do your findings in this explore these examples apply to figures other than triangles? For instance, if you know that quadrilaterals JKLM and PQRS are congruent, can you make any conclusions about corresponding parts? Why or why not? All right, so put your response in. All right, and so hopefully you had answered yes, because that all applies just because it's a triangle of corresponding sides. Now it goes from 3 sides to 4 sides to 5 sides. If they're congruent, then all the parts are congruent as well. So with that, let's see if we can apply that to example 5 here. And so hopefully you got 35 centimeters and 170 degrees there. All right, and then a couple questions to finish up to reflect on. So a student claims that any two congruent triangles must have the same perimeter. Do you agree? And then explain. And then if triangle PQR is a right triangle and triangle PQR is congruent to triangle XYZ, does triangle XYZ have to be a right triangle? Why or why not? So you'll answer in Edpuzzle, but then be ready to share out your answers for those two in class as well.